So we are tasked with a question where we have to determine the domain of h of x when h of x equals f of x times g of x. If f of x equals the square root of x minus 9 and g of x equals x squared minus 16x plus 60 over x minus 10. Now the first thing I'm going to notice is the function that we're trying to find the domain of is a function that is created by multiplying two functions together. Now that is a product. That's a product of two functions, okay? So that's a product operation. Now, when you are trying to find the resulting function's domain that is made up from two other functions multiplying each other, okay, that domain you're trying to find will be the common domain between f of x and g of x. So h of x's domain will be the common domain between f of x and g of x. So what we essentially have to do here is figure out where does f of x and g of x's domains overlap. That is the common domains. So I'm going to figure out the domain of f of x first. Okay, and note f of x is a radical function. Okay, there's that square root value there. And since there is a square root value, there is a restriction on x. Remember, you cannot have a negative value underneath a root symbol. So that means x minus 9 has to be greater than or equal to 0. So we can solve for this restriction by adding 9 to both sides. And we are going to get a domain where x has to be greater than or equal to 9. Okay, so I'm going to start off by drawing a number line because I'm more of a visual person, and these are the values x can be. So for f of x, 9 is included, right? Because if we square root 9 minus 9, we'll just get the square root of 0, which we can do, it's 0. So 9 is included in this case, so I'm going to put a closed circle, and x has to be anything greater than that. So we have to be larger than that. And I'm going to notate this as fx. Now I'm going to find the domain of g of x now. So g of x equals x squared minus 16x plus 60 over x minus 10. Okay, so I want to show you something that can possibly happen and show up in questions, which can confuse people. Let's imagine we decide to factor the top, which is a good thing to do. It helps us kind of visualize that graph a little better. And you'll end up getting x minus 6 multiplied by x minus 10. Now notice we have these two factors that can cancel out. Now this is where people make mistakes. They say, okay, well x can be any real number. There's no restrictions. But this is not true because we care about the original function g of x. The original function g of x includes all of this. So the domain of g of x will include this non-permissible value. So this non-permissible value will be found when x minus 10 cannot equal 0. Okay, so we're finding the domain of the original function g of x before we factor, before we cancel anything out. So if we add 10 to both sides, we will get x cannot equal 10. Okay, so x cannot equal 10. Now, you can probably notice this is a whole, okay? It's not an asymptote because it's able to cancel out. So this is a little bit of review, but it's good to understand. This is a whole in our graph of g of x. But what we really care about is the domain of g of x. So the domain of g of x can be x. As long as x is not 10, it can be any real number. So if we wanted to represent that on our number line, if we draw 10 here, and we do an open circle, meaning it's not included, so not included, well, we can be any other number as long as we're not 10. and this is our g of x function. Now we're pretty much there. We just have to figure out where does f of x and g of x overlap. That will help us determine h of x's domain. So I'm going to represent that in the blue pen. Okay, h of x's domain is anywhere these two overlap. So 9 is included in both. Remember we did that shaded in circle. So we can be 9 here, and then we can go all the way up to 10, and we're going to skip 10 because it's not included in one of our domains. So we're going to get as close to as 10 as we can, skip it, and then we can go on forever to positive infinity. So if we wanted to represent h of x's domain, I'm going to write it in set builder notation first. Well, x can be any number greater than or equal to 9 as long as x does not equal 10, and anytime x is a number that falls in these restrictions, it can be any real number. So there's set builder notation. Let's quickly write it in set interval notation. So 9 is included, so I'm going to make a square bracket, so included. We're going to go up to 10, but we're not going to include it. So we're going to do a round bracket there. And we're going to jump it, so 10's not included. Then from there, we're going to go to positive infinity. And remember, you can never equal infinity, so it's a round bracket as well. And this is just a symbol saying and, right? So we have that showing that whole. That's allowing us to jump over 10 and not include it. And there is your domain of h of x.